Okay, the next thing I'd like to discuss in reference to Unit 3 with IO management, specifically as we're talking about the IO API inside of Java, the java.io package, would be the character stream classes. So previously, we talked more about the input stream and the output stream classes, and those are classes that allow us to read at the byte level, but we might also want to read at the character level. And so we have character stream classes in Java that allow us to do just that. So just a quick overview of this slide deck is that we'll do a quick introduction for character stream classes. Then we'll talk about the types of character stream classes that we have in Java. And then we're going to look at it from the reader stream classes. We'll talk about the hierarchy, the constructor, the subclasses, and the methods for the reader stream classes. And then we'll pivot on to the writer stream classes, and we'll talk about what the writer's class, what the writer class declaration is, the hierarchy of the writer class, the constructor, the writer class, subclasses, and the writer methods. So just a quick introduction of the character stream classes. So in the previous slides, we learned that the byte stream class provides sufficient functionality to handle 1 byte, i.e. 8 bits of any type of IO operation. But of course, that's incompatible to work directly with 16-bit Unicode characters. So to overcome this problem, Java had to add a character stream class to support characters. So character stream classes in Java are used to read and write 16-bit Unicode characters. So in other words, character stream classes are mainly used to read characters from the source and write them to the destination. And they can perform operations based on characters or char arrays and strings, right? It's usually human readable things. So note, Unicode is a 2-byte 16-bit character set having a total of 65,536 possible encodings, possible values. Or another way of expressing that is 2 to the power of 16. So notice, if you ever want to know what the number of possibilities are, you could always take the number of values that you can encode on a bit. So 2 outcomes, and then you can just take it to the power of the number of bits in that sequence. So that's the number of different possible characters. There's only about 40,000 characters that are used in practice. And so the rest are reserved for any future purposes. So Unicode can handle most of the world's living languages with still about 1/3 of the possible encoding space left over. So this is, you've seen expansions to Unicode sometimes with emoji character sets and whatnot. Okay, so types of character stream classes in Java, like byte stream classes, character stream classes also contain 2 kinds of classes. They are named the reader class, the reader stream class, and the writer stream class. So again, let's try to understand the differences between these by examining them one by one, like we did with the input stream and the output stream. So here, the reader stream classes are used for reading characters from files or from wherever the source is. So the reader is an abstract superclass for all the subclasses, such as buffered reader or string reader or char array reader. It implements the closable, the auto-closable, and the readable interfaces. And the general syntax of the reader class looks like this. So public abstract class reader. So it itself is an abstract class, the mother of all other reader classes. So it can't be directly instantiated. It directly extends object. And then it's going to implement the interfaces of readable and closable. So it can be both read and it can be closed. So if we want to look at the hierarchy, the classes belonging to the reader stream classes are very similar functionally to the input stream classes. The only difference is that the input stream uses bytes, whereas the reader stream class uses characters. And in fact, both byte and character stream classes use the same methods. Therefore, reader classes can perform all the same operations that are implemented by the input stream classes. So the constructor of a reader class, you have the reader constructor, the default constructor, which forms a new character stream reader whose critical section will synchronize on the reader itself. And then you have a reader constructor where you can pass in an object that serves as a lock. And so this form of the constructor creates a new character stream reader whose critical sections will synchronize on the specified object. And again, we'll discuss this more in detail when we start looking at the concrete classes. So the reader class in Java defines the following constructors with protected access modifiers. Well, clearly, I feel like I should move that up there. There we go. Okay. And let's look at some of the subclasses for reader. So you have a buffered reader, and it's going to probably look very similar to some of the classes in the input stream. So we have a buffered reader. This class is used to read characters from the buffered input character stream. And again, buffered means that you can have like a sequence of data that's stored in the stream. You have a car array reader. This class is used to read characters for the character array or car array. You have a file reader. So this class is used to read characters or contents from a file. You have a filter reader. This class is used to read characters from the underlying character input stream. You have an input stream reader. So this class is used to translate or convert bytes to characters. You have a pipe reader. This class is used to read characters from the connected piped output stream. So you can pipe between input and output streams. You have a string reader. This class is used to read characters from a string. And a pushback reader. This class allows one or more characters to be returned to the input stream, where you push them back. Okay, and the reader class defines the following methods. So here we have a read method, right? And so this is going to return an integer representing the next character present in the invoking input stream. And since a character is encoded as two bytes, that and it's any value between 0 and 65,000 and some change there, then it could be represented as an integer as a decimal value. And it returns a -1 when the end of the input is encountered. You have a read method, another read method. It's an overloaded method where you can also pass in a character array. And so this method is used to read up to the buffer length characters from the specified buffer. And so it returns the actual number of characters successfully read, and it will return a -1 when the end of the input is encountered. So that's the int return value here. You also have a read method that has 3 parameters. You can pass in a character array that represents a buffer of characters, and then you have a location, and then you have the number of characters you want to read. So this method is used to read up to the number of characters from the buffer starting at the specified location. Again, these are the exact same parameters as per the input stream, only instead of thinking of this in terms of bytes, we're thinking of it in terms of characters. We have a mark method. This method is used to mark the current point in the input stream that will remain until our number of characters are read. So let's just know where in the input stream we're at. We have a reset, which is used to reset the input pointer to the preceding set mark. So again, reset, that's what this mark supported method is for that we had talked about earlier. You have the, you have the skip. I'll get back to that, but let's continue with skip. So you have skip where we can pass in a long numerical value. And so we'll use that to skip the specified number of characters from the input stream and then return those number of characters that are actually skipped. We have a ready method. So this returns a true value if the next request of input is ready. Otherwise, it returns false. So it allows us to know whether we can read, if we can read off the input stream at this time or not. We have a close method. So this method is used to close the input stream. And if the program attempts to read the input any further, it will generate an IO exception. And then we have mark supported, and that returns a Boolean value true if mark, reset are supported on the stream, where we can mark our position and then reset it. So all the methods provided by the reader class, except for mark supported, will throw an IO exception on error conditions. Okay, so let's move from the reader class to the writer stream class. So the writer stream classes are used to write characters to a file. So in other words, they're used to perform all output operations on files. The writer stream classes are similar to the output stream classes with only one difference, and that's the output stream classes use bytes to write, while the writer stream classes uses characters to write. So in fact, both output stream and writer stream classes use the same methods. So the writer class declaration is an abstract class that acts as a superclass for all other writer stream classes, and it implements the appendable, the closable, and flushable interfaces. That means that anything that is writable can be flushed, it can be closed, and we can append new data into it. So the general syntax for the writer class is given as follows. It's a abstract class writer. Its parent is the object class, and it implements these interfaces. So if we want to look at the hierarchy, the writer class is designed to write 16-bit Unicode characters to the output stream. And so since the writer class is an abstract class, it can't be directly instantiated. Therefore, the subclasses of the writer class are used to write the characters onto the output stream. So here we can see, like, for instance, the writer stream would be effectively extended by buffered writer or car array writer or filter writer, print writer, string writer, pipe writer, or output stream writer, which itself would then be extended by file writer. So the writer class in Java defines the following constructors with protected access modifiers as follows. So you have a writer, a default writer constructor that constructs a new character stream writer whose critical sections will synchronize on the writer itself. Or you also have the ability to pass in an object in which to lock your writer onto. And this form of the constructor constructs a new character stream writer whose critical sections will synchronize on the given object. So let's understand the subclasses of the writer class in a quick, brief description here. Here are subclasses. We saw the hierarchy for them. Let's just give a quick explanation for what each of those subclasses do. So we have reference. So the buffered writer is the class that's used to write characters to the buffered output character stream. File writer is an output stream class that writes characters to a file. The car array writer is an output stream class that writes the characters to a character array. The output stream writer is the output stream class that translates or converts from bytes to characters. The piped writer is a class that writes characters to a piped output stream. So you write from one to the other. The string writer is an output stream class that writes the characters to a string. The print writer is an output stream class that contains print and println. So we've actually used these output streams previously. That was our system.out effectively. That's an instance of the print writer is our system.out that we've used. And then we have filter writer. This is the class used to write characters on the underlining character output stream. So let's look at some of the writer methods in Java. So to write the characters to the output stream, the writer stream class in Java defines the following methods. And note, all the methods defined by the writer stream class throws an IO exception if any errors occur. So we have the write method. The write method is used to write the data to the invoking output stream. Then we have the ability to overload that, where write takes in an integer value. So here, the method is used to write a single character to the invoked output stream. And recall that a character can be represented as an integer. We have the ability to pass in a character array that we'll call buffer. So this method is used to write a complete array of characters to the invoking output stream. We have another overloaded write method that takes in the character buffer, the location, and the number of characters. And just like with the output stream method, this will work the same way, but instead of with bytes, it'll work with characters. So this method is used to write a subrange of the number of characters from the character array starting at the specified location in the output stream. We also have a write method that takes in a string. So this method is used to write the string to the invoking output stream. We have a write method that takes in a string and then takes in an integer value of location and an integer value of the number of characters. And this method writes a subrange of the number of characters from the string starting at this specified location. We have a close method, of course. All streams should have a close method. This method is used to close the output stream, and it will produce an IO exception if an attempt is made to write to the output stream after it's been closed. We have a flush method. This method flushes the output stream and writes the waiting buffered characters to whatever the destination is. It forces a write. We have an append where we can take in a character and it's going to then return back a writer. So the append method appends the character to the end of the invoking output stream. It then returns a reference to the invoking output stream. We also have append, which is overloaded to take in a car sequence data type, and it also will return a reference of the writer. So this method appends cars to the end of the invoking output stream, and it returns a reference to the invoking output stream. Excellent. And that's just a quick overview of everything that is inside of our the character streams and the distinction between the character streams and the byte streams. Does anyone have any questions related to that?